Yeah, if you can hear me, use the chat. If you can hear me, use the chat. Can you hear me? If you can hear me, please react by liking the voice. Yeah, you can hear me. Yeah, Utibe, I can see your chat. That means the gadgets are working. Can you still hear me? Type, type yes sir again if you can hear me. Type yes sir again if you can hear me today. I'm waiting. If you can still hear me, type yes sir again. For whoever is online, if you can hear me, type yes sir. I'm waiting. Okay, okay, I can see your chat. All right, you're welcome to today's class. We're having circle geometry to talk about. Circle geometry. Um, I won't bore you with so much details. So you know what a circle is, okay? A circle is basically a shape, like a perfectly round shape. All right. One unique thing about a circle is that the point from the center to any point on the circumference is what? Is always the same. All right. So if this is a circle, all right, from this point, which if this is the center, this line here is the circumference. All right. So from this point here to any point on the circumference is always the same. I get it. You understand? That is from here, the distance from here to here is the same distance from here to here. Same distance from here to here. Am I communicating? So that is basically what a circle is all about. All right. Now, so that is pretty much what this is all about. A circle. Now, we are going to go further into the theorems of a circle. But before then, I have to explain some certain terms in terms that are used in circles. Are you getting it? The first term we talk about is the radius. Okay, the radius is the what? Is the line. Some mathematician can say it is a line that runs from the center to any point on the circumference. So if I draw a line from here now to here, this is a radius. Okay, this is also another radius. This is another radius. This is another radius. This is another radius. Any line at all that runs from the center of the what of a circle to any point on the circumference is what is the radius. Am I communicating? Some mathematician will say it is the distance from what from the center to any point on the circumference, which is still what pretty much correct. Are you getting it? All right. So it's the length of the line that runs from the center to the circumference to any point on the circumference is what is the radius. Are you following? So that's pretty much that. All right. Is radius singular is radius and plural is radii. Right? When we have plural more than one, we use what radii for it. All right. So a chord, a chord, a chord is a straight line that runs from one point on the circumference of the circle to another point. Okay, the straight line that runs from one point on the circumference of the circle to another point. All right. So if I draw a straight line that runs from here to here. This is a chord. All right, this is a chord. One thing about a chord is that number one, it must be a straight line. Number two, it must run from one point of the circumference to another. All right, like from here to here is another chord. From here to here. So long is a what? Is a straight line. So long is a straight line, and so long as what? It's what? It joins 2 points on the circumference. Okay, we call that line a chord. All right. This is also a chord. This is a chord. This is a chord. Any straight line at all that runs from one point on the circumference to another is a chord. Are you getting it? We all know, we know that the longest chord in the longest chord in the circle is a radius, and that longest chord is a chord that passes through the center of the circle. So if this is a chord that passes through the center of the circle, I get it. All right, it is the longest chord, okay? And that chord is called a what? A diameter. It is called a diameter. Now, if you observe, you will see that the chord is from this, the chord is actually 2 radii. All right, 2 radii is a chord. Look at from here, this is the center, this is circumference. So from here to here is a radius. From here to here is a radius. So both of them make up the diameter. And that's why we'll say what diameter is equal to what? Radius plus radius. Right? That is 2 radius. All right, 2 times r will give us what radius. So if the diameter of a circle is 10 centimeters, the radius will be what? 5 centimeters. If the diameter of a circle is 7 centimeters, the radius will be 3.5 centimeters. If the radius of a circle is 16 centimeters, that means the diameter, I get it, the diameter will be 32 centimeters. So the diameter is always twice the radius. Are you following? Okay, that's pretty much that. If you have question, you ask. If you have question, you ask on the live chat. I will see. Okay, so that's pretty much that. Now, we have what we call an arc. We have what we call an arc. An arc. An arc. Now, an arc is a line. If I draw a circle, for example, and I choose these 2 points, for example, all right, the arc is what? Is a single line that runs along the circumference of the circle, joining 2 points together. Okay, it joins 2 points on the circumference together, but it's just what? It just runs along the circumference of the circle. For example, look at these 2 points now, okay? A line that runs along this circumference, I get it, is an arc. From here like this, down here, it is an arc. All right? From here like this, down to this point. So that is pretty much what we are talking about. All right? So, arc. Arc. This is an arc. All right? And you should know that the arc is actually a part of the circumference of the circle. It's an arc. So if I join this line, this point now to this point, directly with a straight line, of course, you know that this straight line is called a chord. It is called a chord. All right, it is called a chord. Why is it called a chord? Because it's okay. Why is it called a chord? Because it is a straight line that runs from one point of the circumference to the other. All right, so it's a chord. So if I draw a chord here now, that chord divides the circle into 2 parts. Any chord, every chord divides the circle into 2 parts. If the chord is not a diameter, you divide it into 2 unequal parts, 2 parts that are not equal. 2 unequal parts. And what are those unequal parts? Very easy. We have each part is called a segment. Each part is called what? A segment. That is, a chord divides the circle into 2 unequal parts. Each part is called a segment. The smaller part is called the minor segment. I get it. While the larger part is called the major segment. All right. The smaller part is called the minor segment, while the larger part is called the major segment. So this is the minor segment. Why this is the major segment in this case. All right. I hope you understand. Now, without delaying much of our time, we're going into the theorems of a circle. The theorems of a circle. Theorems of a circle. By the way, if you have a question, you can use the chat, the live chat. I will see it. If you have a question, you can ask using the live chat, and I will see it. All right. If you have a question, you can use the live chat, and I will see it. All right. Ask questions if you have. All right. I'll be checking from time to time. All right. Theorems of a circle. Now, before we go into the theorems of a circle, there's what we mean when we mean. There's what we mean when we say an arc or a chord subtends an angle at the center, or an arc or a chord subtends an angle at the circumference. That's what it means. I guess that's what it means when we say an arc subtends an angle at the center, or an arc subtends an angle at the circumference. So what does it mean for an arc to subtend an angle at the center or at the circumference? It means what that angle, an angle is formed by two straight lines, right? When two straight lines meet at a point, at the point, for example, this point, okay, this is an angle. An angle is formed when two straight lines meet. Two straight lines meet. They form an angle. They form an angle. All right. So this is the angle that is formed when these two straight lines meet. So when we say an angle is subtended by an arc, it means that that angle is formed by two straight lines that are originating from the ends of that arc. I repeat, when we say an angle is subtended by an arc, I get it. It means that that angle is formed by two straight lines that are originating from the ends of the arc. I get it. Now, if they say they subtend at the angle at the center, it only means that the two straight lines meet at the center. The two straight lines meet at the center. I will give you an example. For example, let's say this arc subtends an angle at the center. Let's say look at the center. Are you getting it? This arc now. This arc. If we say this arc subtends an angle at the center, what does it mean? It means that the two lines that joins to form that angle we are talking about, okay, originated from the ends of the arc. Here are the ends of the arc. This is one end. Look at the end. You know the arc runs from here to here. So the ends of the arc will be this and this. So the two straight lines that form the angle must have originated from these two places. And once they are originated from these two places, okay, they meet at the what? At the center. That means to say what? The angle is subtended at the center. It is subtended by what? By an arc at the center, which means the two straight lines originate from the ends of the arc and they met at what? At the center of the center. That means the angle we're talking about is this, okay? That means this angle was subtended by this arc at the center. I hope you are getting it. I hope you're getting it. I hope you understand. Yes, I see you, Chisomaga. They are just coming. Okay. That's good, all right? You have a question you asked. Okay, this is the center. The two angles that form the two lines that form this angle are originated from the ends of the arc. So that means it is this arc now that subtends this angle at the center. This arc that runs like this. Remember, I told you that the arc runs along the circumference of the circle. So this arc that runs from here to here subtends this angle at the center. Why? Because the lines that form this angle are originating from the ends of the arc. Hope you understand. So that is that about that. So this angle was surrounded by this arc at the center. This angle, this arc too can subtend another angle at the circumference. Okay, let's say it is this place that the angle that is surrounded at the circumference is. That means the lines that forms this angle met at this point. I guess it. Of course, if they were subtended by this arc, that means they are originating the 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 lines that form that angle is originating from the ends of this arc. That means it's like this. The first line goes here, the second line goes here, right? So which means this angle now is the angle we're talking about. The angle subtended by this arc, right? At the circumference. So this angle was subtended by this arc at the circumference. Why? Because the two lines that forms this angle are originating from what? From the ends of this arc. Again, this angle self was obtained by this same arc because why? The two lines that form the angle was originating from the ends of this arc. I hope you understand. I really do hope you understand what I'm explaining here. All right. All right. So that's that. That's that. That's that. That question you asked, who? That question you asked. Now, theorem one. Now, in geometry, the questions you solve, you use the theorems of the circle, of the circle. We have about 7 of them. All right, we have about 7 theorems of a circle, and those 7 are used to solve questions. If you can know all the 7 theorems of a circle, and you know how to apply all the 7 of them, you know how to apply them, you'll be able to solve any question you find out, any question that you come across in WAEC, JAMB, NECO, or post-UTME, any question at all. These 7 theorems can be used to solve them. Now, when you look at a question, the question is always in the diagram. What you are looking out for, when you look at the diagram, you are searching for a means by which you can apply any of the 7 theorems. I will give you the theorems of the circle. All right? I will give you the theorems of the circle. I will give you the theorems of the circle. Are you following? I will give you the theorems of the circle, and then your aim is to find a way. Whenever you see any question, you are searching for an opportunity to apply any one of the theorems. It might not be a theorem that will lead you to the final answer. It might not be. Your own aim there is to look at the diagram and find a way of applying any 7 of these theorems. When you can comfortably apply the 7 theorems, there is no question you can solve. There are some questions that you will see. For you to get to the final answer, you have to apply like 2 or 3 or even 4 theorems of what? The circle. It doesn't matter. Your aim is to look at the diagram, and with the 7, you are equipped with the knowledge of the 7 theorems of a circle. Are you getting it? Then your aim is to look for how you can apply those theorems and get an answer. It might not be that you are getting the final answer, but the answer you get might lead you to get another answer. It might lead you to a final answer, as the case may be. And that is how it is done. So, as we move on, I'm going to give you each of the theorems. The first theorem, theorem 1. Theorem 1 states that let me state it here. The angle subtended by an arc at the center is twice the angle it subtends at the circumference. I will break it down for you so that you understand how to apply them. It's actually very simple. The angle subtended by an arc at the center is twice the angle the same arc subtends at the circumference. What do I mean by this? We have two angles. One is at the center and the other at the circumference. One is at the center and the other is at the circumference. Are you following? We have two angles, one at the center, one at the circumference. The one at the center and the one at the circumference were subtended by the same arc. Take note of it. You are going to look at the two angles, one at the center of the circle and the other one at the circumference of the circle. And then both of the angles are subtended by the same arc. That means the angles, the straight lines that form them originate from what? From the ends, from the two ends of the what? Of the arc. Like this. Look at one circle. Okay? All right? Look at the circle, and then this is the center. Let's say this is the arc. The arc runs from this point to this point, A to B, point A to point B. And then there is an angle that was subtended by this arc at the center. Look at it. Remember, O is the center. This point is O, point O is at the center. And this is the arc, right? The line that forms this angle originated from the ends of this arc. Are you getting it? They are what? At the center. Are you getting it? Then the other one was subtended by what? By the same arc, but at the circumference. Like this. So you see that these two angles are what? Are subtended by, they were subtended by what? By the same arc. This arc subtends this angle at the center. This same arc subtends this angle at what? At the circumference. So what this theorem is trying to tell us is that what? This angle now is twice this. The angle at the center is twice the angle at the circumference, provided that both of them were subtended by the same arc. Don't understand? You tell me. Provided that they were subtended by the same arc. Are you getting it? So that is that. So long as they were subtended by the same arc, that means the one at the center is always twice the one at the circumference. That means if the one at the center is 100, the one at the circumference will be 50. If the one at the center is 60, the one at the circumference will be 30. If the one at the center is 70, the one at the circumference will be 35. If the one at the circumference is 50, the one at the center will be 100. If the one at the circumference is 40, the one at the center is what? Will be 80. The one that is at the center is always 2 times the one at the circumference. Are you following? So that is pretty much. It might not even take this form. It might take this form. Let's say this is a circle and this is the center. Okay. Then we have this arc. Let's say this arc is P and this one is Q. And this arc subtends this angle at the center, right? Then we now see another angle here. So many people will think it will take this format. No, it might not take this format. The most important thing is that both angles were subtended by what? By the same arc. And one is at the center, the other one is at the circumference. Look at these two angles now. If you're not careful, you would think it's a little bit confusing. No, it is not. Okay, if you look at this angle now, this angle was subtended by this arc. It is this arc that subtends this angle at the center. This is center O. And this same arc too subtends this angle at the circumference. This is a circumference now. So this one is at the what? Is at the circumference. This one is at the center. And they were both subtended by what? By the same arc. Which means this one too will be twice this. That means 2 times this will give us this. Are you following? That rule must be obeyed. I am hoping that you understand very well. Let's see how we can solve a question like a question in this case. Let's look at this circle like this, which I can have math. where I can find questions, multiple questions that we can use. No problem. All right. So, sorry. Oh, let's say we have this. Okay, we have this. Let's say we have this. Then this is 40 degrees. Let's say this one is 140 degrees. This is P, this is Q, and this is R. This is O. Everybody is 140. Okay? So what do we do? PQR. So let's say they gave a question. They said the diagram above shows a circle PQR of center O. Now say angle P angle POR equals 140 degrees. Okay. Let's say okay. All right. That said, find a angle PQR, B angle OR. Let's look at that. So we are given this question. The diagram above shows a circle PQR of center O. Angle POQ equals 140 degrees. Now say find angle PQR, and then they say find angle ORP. So how do we solve a question like this? I want to know if it is visible. Okay, the diagram above shows a circle, whatever. So, how do we solve a question like this? It's very simple. Remember, I told you that we are going to be looking out for a theorem that we can apply. And luckily for you, I've only taught you one theorem, and that is what the the angle subtended by an arc at the center is twice the angle the same arc subtends at the what? At the circumference. That is what I have taught you. All right. So you are looking for an opportunity to apply that theorem. All right. So you look, you check. Are there angles, or is there any case where we have angles that were subtended at the center and circumference, and both were subtended by the same arc? That's what you are checking. Okay, that's what you are looking out for. All right. Two angles. One at center, the other at circumference. I guess it's okay, that was subtended by the same arc. If you check it very well, you'll find out that this angle here was subtended by what? By this arc, right? This arc subtend this angle at the center. This same arc subtend this angle at the circumference. If you watch, if you look at it very well. All right. The two lines that form this angle are originating from the ends of this arc, right? The same way, the two angles that form this angle, the two lines that form this angle, are originating from the ends of this arc. So this arc subtends what? This one at the center. This same arc subtend this one at the circumference. So which means this one will be twice this. Are you getting it? But how do you write it to get your maximum mark? It's very simple. You want to prove that this, you want to use this to find this, right? Do you understand? You want to use this to find this. In geometry, they are using the relationship between two angles to find one of the angles. And that's where the theorem gives the relationship. Okay? So this theorem now has already given this the relationship between these two angles. So all I just have to write is angle POQ, that is, angle POQ is what? If you follow the side, the path, POQ, POQ, POQ. So the angle is always at the middle, which is this. Okay? It's always at the middle, which is this. POQ will be here. I get it. So angle POQ is what? 140 degrees. If you look at it very well. 140 degrees. You understand? You get it? Now, that's not what we are going to answer. So from the theorem, we know that this angle is twice this. What is this angle? Angle POQ. What is this angle? Angle PQR. All right. So that means angle POQ equal to what? 2 angle PQR. That is what the theorem is trying to tell us. Is there anybody that doesn't understand? If you don't understand, you let me know. So I will know what to do. If you don't understand, you let me know. So I will know what to do. Okay. Angle POQ equal to 2 angle PQR. And that is just mathematically representing this one, this theorem. The angles of by an arc at the center is twice the angle the same arc subtends at the circumference. That means this one will be twice this because this arc subtends this angle at the center, this same arc is subtending this angle at the center. This is a very important topic because it comes out in every mathematics exam, whether WAEC, NECO, any exam, you see. Very important. All right? So, now, we all know that what angle POR is what? Is it POQ? Sorry, it's not POQ, it's POR, sorry. POR now, right? POR. POR. Okay, that is it now, POR. It was my mistake. Angle POR, what is it? 140 degrees. That means it's what? 140 degrees equal to what? 2 PQR. PQR. Now, when you write this, angle POR equal to 2 angle PQR, if you are writing WAEC, you must put your reason in brackets for writing this. Now, we all know that what? That we wrote this because of this theorem. You are just trying to say that what? The angle surrounded by an arc at the center is twice the angle is something like what I said. That's what you are trying to say. Okay? So, but you put it in brackets. Why do you write this? Just write angles subtended by an arc at the center and circumference. When you write it like that, you will know what you mean. All right? Any question, please? Because you are trying to say that what? The angle subtended by an arc at the center is twice the angle the same arc subtends at the circumference. All right? So that is basically that. So in WAEC, this is what they will see for them to give you a mark. If you just write something like this and you didn't put something like this here, you will get it wrong. You will not be given your mark. All right? So now, 140 degrees equal to 2 angle PQR. And remember that one of this thing you are looking for is angle PQR. So you're being able to apply this rule. It's trying to give you the answer to your first question. So from here now, what do? I divide both sides by 2 here. 2 here 1, 2 here 70. That means angle PQR equal to 70 degrees. Communicate with me. Do you understand? If you sincerely don't understand, you put on the chat box that you don't understand so that I will know what to do. If you don't understand, tell me you don't understand. So I will start from the beginning. If you don't understand, you tell me that you don't understand so that I can start from the beginning. I'm waiting. If you understand, just tell me that you just write you understand on the chat section. All right? If you understand, tell me you understand so that I can continue. I'm waiting. If you don't understand, tell me you don't understand. If you understand, write on the chat, um, the, the chat section that you understand so that I can move on. Okay, I'm seeing someone. Someone have typed, I understand, sir. Uh, okay, okay. I'll continue. That's enough for me. Even if the others are just online, but they are not really online. You understand what I mean? I'll just continue. That's okay for me. So that is that. Angle PQR is equal to what? 70 degrees. All right. So let's continue. Now, instead we should find angle ORP. Yes, ORP. 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 That means the angle is at what? At R, right? Which is this angle. ORP. Right? So we are looking for this angle, right? So how do we look for it? This one, to get this, we need to use an idea from plane geometry. All right? Plane geometry. First and foremost, this is a what? This is a triangle. All right? This is a triangle. If you check it very well. POR is a triangle. Are you getting it? And one thing about this triangle is that what? From here to here is a radius. All right? Look at it. This is the center. This is the circumference, right? So from here to here is a radius. From here to here too is what? It's another radius. All right? From here to here is a radius. From here to here is another radius. Are you getting it? That means we have two radii of the same circle. And from the rules of a circle, the center to any point on the circumference is always what? Is always the same. From the center to any point on the circumference, they are always what? They are always the same. So which means this is a radius, this is also a radius. That means this side will be equal to this side. That means in this triangle now, two sides are equal. In this triangle, two sides are equal. What are the two sides? These two sides. All right. Now, what kind of triangle do we have two sides equal? That is isosceles triangle. Isosceles triangle. In an isosceles triangle, two sides are equal. Two sides are equal. So one thing you have to know about an isosceles triangle. Thank you. I'm seeing that someone, okay, Mustafa, is saying that he understands, which is fantastic. All right. Now, isosceles triangle. In an isosceles triangle, two sides are equal. In an isosceles triangle, two sides are equal. Okay. So That means this is an isosceles triangle. All right. And one thing about an isosceles triangle is that what? Base angles of an isosceles triangle, they are equal. I will explain to you. If we have this as a triangle now, if this is a triangle, all right, if this is a triangle and it's an isosceles triangle such that these two sides are equal. If these two sides are equal, are you getting it? The base of the triangle will be the third side that is not equal to the other two sides. The third side that is not equal to the other two sides is what? Is the base, is the base. Are you getting it? So which means this is a triangle, this side is equal to this side. That means this is the base of this triangle. This is the base. And the rule is that what? The base angles of an isosceles triangle are equal. So what, where are the base angles? This is a base angle and this is another base angle. This is a base angle, this is another base angle. That is the angles, the two angles that are on the base. Are you getting it? That is the base angle. So which means these two sides, these two angles was equal. I will give you another case. When we have a triangle like this, and these two sides are equal, I guess the third side that is not equal to the other two sides will be this, right? That means this is the base, okay? So where are the base angles? The two angles, we have three angles of the triangle, okay? The two angles that are on the base, look at the base here, the two angles, this and this. So these two angles will be equal. That is what we mean by base angles of an isosceles triangle are equal. Any question? If we follow it that way, we follow it that way, all right, this is a triangle, and this side is equal to this side. Since both of them they are radius. So if this side is equal to this side and both of them they are radius, this side it becomes the base, right? And the base angles are these two angles, OPR and ROOP. OPR, which is this OPR, which is this angle, and what? And ORP, this angle, they are equal. Are you getting it? So that's what I want to establish. I want to establish. Okay. So I'll just write angle O. Sorry, these markers are not working very well. Just one marker. So I'll just write it. Angle OPR should be equal to angle what? ORP. Your reason. Remember that your reason is the most important thing. If you don't put it, you will not get it. We just write base angles of an isosceles triangle. Base angles of an isosceles triangle. So base angles of an isosceles triangle, they are what? They are equal. All right. So angle OPR is equal to what? Angle ORP. I guess that is that. I'll just say let them be equal to what? X. Okay? That means this place is X and this place is X. Okay? So if I've established this is a triangle, remember. And another plane geometry theorem is that what? The sum of angles in a triangle, they are equal. The sum of angles in a triangle, they are equal. That means this plus this plus this will be also 180 degrees. I mean, the sum of angles in a triangle is what? 180 degrees. What's wrong with me? What is wrong with me? So the sum of angles in the triangle, they are what? Is 180 degrees. I get it. The sum of angles in the triangle. Okay, sure. Yes. Okay, can you hear me now? Can you hear me now? Can you hear me now? Okay, okay. I think the thing shook somehow. I don't know what made it shook. Okay, thank you very much for pointing out that. All right, let me begin. Now look at it. I was telling you that I was saying that angle OPR and angle ORP, They are what? They are equal. I mean, they are equal. Why? Because they are base angles of an isosceles triangle. Base angles of an isosceles triangle, they are equal. I hope you understand that. Okay. Utibe said she can't really see the board. She can't really see the board. Okay. Okay. Uh, is it like that for everybody? Please confirm. If all of you can't see the board very well, let me know if it's like that for everybody. Let me know what I can do. Is it everybody that cannot see the board, or it's only Utibe? Just in the case. So let me know if I can go and bring my light, if it can help. Okay. The other side. Okay. Mustafa said he can see the board. All right. All right. Is it this other side that you people cannot see, or this left hand side, is he showing very well? Let me, maybe I will be using that place. Okay. Let me see if I can bring the light. I doubt the light will be able to do anything. This is my camera. Let me check, Sha. Let me check if it can do something. I think they've taken light. There's no light again. So we just have to manage it. The only thing is I will use this left hand side. All right. I'll use this left hand side. So that's it. Okay, let me do it like that. Okay. Now look at what I was trying to say. Okay. This is a this is a how do I put it? This is a triangle, all right? This is a triangle. This is an isosceles triangle. I think I've established that this side is equal to this side. Okay, that means these two, this side is the base. Okay, so this is the base. These two are the base angles, so they are equal. You understand? So if they are equal, then um, if they are equal, I will just say they are x. So that's why I will just say angle OPR is equal to angle what? ORP. I hope you understand now. I hope you understand that now. You see it? Angle OPR is equal to angle ORP. Do you understand that? Yeah. So that is it. This angle OPR is this angle. Angle ORP is this angle. So this angle is equal to this angle. That is what I just put here. Reason, I'll just write base angles of an isosceles triangle. Maybe before our next class, I would have gotten ring lights, so everything will be clear. Everything will be very, very clear. But for now, just make do with this. So base angles of an isosceles triangle. Base angles of an isosceles triangle. All right. So that means everything is equal to x. Let's say it is x. All right. So if this is a triangle, that means this angle plus this angle plus this angle, all of them together, when you add all of them together, it gives 180. Because according to plane geometry, sum of angles in a triangle is 180 degrees. According to plane geometry, sum of angles in a triangle is equal to what? 180 degrees. That means, if you agree with me, that means to be angle OPR plus angle ORP plus angle POR equal to 180 degrees. Angle OPR, which is this angle, plus angle ORP, which is this angle, plus angle POR, which is this angle. Okay? They are all, when you add them together, they give you what? 180 degrees. Reasons. You just write sum of angles in a triangle. Bear with me, the markers are not writing very well. Before the next class, I would have gotten all these things fixed. All right? I hope you understand. So that is it. All right? So yes, OPR plus angle ORP plus angle POR equals 180 degrees. Now, if you look at it, angle OPR is actually x. X plus angle ORP. ORP is still x. X plus angle POR. POR is what? Is 180 degrees. Is 140 degrees. You just put 140 degrees. That will give us what? 180 degrees. So x plus x is actually 2x. So you say 2x plus 140 degrees equal to 180 degrees. So the next thing is to collect like terms here. If you collect like terms here, you have what? 2x equal to 180 degrees minus 140 degrees. So 2x equal to what? 40 degrees. So what do you do next? You divide both sides by what? By 2. If you divide both sides by 2, x will be equal to what? 40 degrees over 2, which is equal to 20 degrees. So since x is what? 20 degrees, that means we are looking for ORP, right? That is the second question. Find angle ORP. So ORP is what? X. And x is what? 20 degrees. Therefore, what? Angle ORP is equal to what? 20 degrees. Do you understand? Do you understand? Do you understand? I think with this, I'm going to stop here. I don't want to go beyond 1 hour. All right. Yes. We are only able to do one theorem, and that's because we are just starting. Okay, we are just starting, and all this, I'm just finding my way around it. So in our next class, next mathematics class, I'll continue from where I stopped. All right. Thank you very much for being with me, for staying with me. We'll meet in our next class.